Hi, dear students, welcome to today's class. So, we have gone through the topic that is packing efficiency, and we have seen the packing efficiency in HCP and CCP or FCC structures. We have seen the packing efficiency in BCC and in simple cubic lattice. So, today we'll discuss the topic calculations involving unit cell dimensions, and this topic is also important. You should know the formula and to calculate using that formula. Okay, so we'll go through this topic, that is calculations involving unit cell dimensions. So today we'll discuss the topic calculations involving unit cell dimensions. Okay, so from this unit cell dimensions you can calculate the volume of the unit cell. So now if you know the density of the metal, okay, if you know the density of a metal, you can calculate the mass of the atoms in the unit cell. So here we are going to derive a formula to calculate density, or you can even calculate mass of the substance, number of atoms present, or the cell length of the unit cell. So it is a formula which connects all these parameters, that is density, number of atoms in a unit cell, molar mass, then edge length of a unit cell. So we'll derive that formula. Now if the edge length of the unit cell, okay, edge length of the unit cell of a cubic crystal, so let edge length let edge length of a unit cell, let it be of a cubic crystal, let it be A. You know that A is the edge length of the unit cell. We have taken for packing efficiency also, we have taken edge length as A. So let the edge length of the unit cell be A. Density. Okay, so mainly it is for density. So density of the solid substance, or density of that particular substance, like the density of that solid substance, let it be equal to D, small d. Okay, so density of the solid substance, let it be D. Now let capital M be the molar mass. Okay, molar mass, let it be equal to capital M. It is capital M, not small m, because small m will take another parameter, that is mass. So let M be the molar mass. Okay, so these three you have to remember. Edge length of the unit cell, let it be A. Density of the solid substance, let it be D. And molar mass M. So you know how to find the volume of a unit cell, isn't it? How will you find the volume of a unit cell? Volume of a unit cell, if the edge length is A, then volume is A cube, isn't it? So volume of the unit cell is A cube. Now how will you find the mass of the unit cell? So mass of the unit cell. How will you find the mass of something? That is total number into mass of each substance, isn't it? That is how you find the mass of a unit cell. That is, if you take a unit cell, in that if there is only 4 atoms, then that number of atoms present into mass of each atom, that will give you the mass of the unit cell. Similarly, the mass of the unit cell, it is equal to number of atoms in unit cell, number of atoms in unit cell multiplied by mass of each atom. That is how you find the mass of each atom. So that is how you find the mass of the unit cell as a whole. To find the mass of the unit cell, you should know how many atoms are present and mass of each atom. So when you multiply that, the total number of atoms into mass of each atom, when you multiply, you will get the mass of the unit cell. So this number of atoms in a unit cell, we'll take it as Z. Okay, number of atoms in unit cell, let it be Z, and this mass of each atom, let it be small m. Okay, so this is Z and this is small m, this is capital M. Fine. So mass of the unit cell we have taken as Z into m, or you can take it as Zm. Now mass of an atom, how will you find mass of one atom? Here we have written mass of each atom and number of atoms in a unit cell. So how are you going to find the mass of each atom? That is next. That is mass of an atom, mass of an atom present in the unit cell, present in the unit cell is equal to, and that we have taken as small m. Okay, so that is equal to, how we are going to find the mass of the unit cell, sorry, mass of an atom present in the unit cell, that is capital M, that is molar mass divided by Na. Na is Avogadro number. So it is capital M divided by Na, that is Avogadro number. Now we are going to find the density of the unit cell. So our aim is to find the density of the unit cell from mass of an atom. So density of the unit cell, density of the unit cell, that is D. Okay, density is D. You know how to find the density. How will you find the density? Density is equal to mass by volume, isn't it? So we'll write it as mass of unit cell, because you are going to find the density of the unit cell. Density is mass by volume. So density of the unit cell will be equal to mass of the unit cell by volume of the unit cell, isn't it? Volume of unit cell. So density of the unit cell is mass of the unit cell by volume of the unit cell. Now what is the mass of the unit cell? Okay, here we have already derived mass of the unit cell is Z into M. Okay, so write it here, mass of the unit cell as Z into small m. It is small m because it is mass of each atom. So Z into M divided by volume of unit cell. Okay, volume of unit cell you can see here. Volume of the unit cell is A cube. That you have to write it here. Zm by A cube. Okay, so it is Zm by A cube. Now this small m, you can see here, small m we have already derived, that is mass of an atom present in the unit cell, that is small m, it is capital M by Na. This is capital M by Na. This we are going to substitute in the place of small m. Okay, so Z into, this is capital M by Na, isn't it? Small m is capital M by Na, then you have A cube. So you got your Zm is capital M by Na. Okay, so this capital M you have to substitute here. Instead of this capital small m, you have to substitute this capital M by Na, that is molar mass by Avogadro number. So you'll get Z into capital M by A cube Na, or you can write it as Zm by A cube Na. Zm by A cube Na, that is the density. So this is the equation, Zm by A cube Na. So what you have to study here is, you just have to remember this formula. This derivation is not important. You don't have to study that the way you got this formula. You just have to study this formula, that is density is equal to Zm by A cube Na. That is the formula what you are going to study here. So Z is the number of atoms in a unit cell. Capital M is the molar mass. A cube is what? A is the edge length, it's cube. Then Na is Avogadro number. So this is how you find this formula. So you just have to remember this, that is density is equal to Zm by A cube Na. Now based on this formula, you have problems to study, and that problems is important more than this derivation. Okay, so you have to study the problems given in your textbook. There are 3 problems given in your textbook. We will be discussing those problems next, and those problems are important more than this derivation. So we'll see how to solve this problem. So here in the question it is given that it is forming CCP lattice. CCP lattice, or we can also say it as an FCC crystal. Okay. So and it is having an edge length of 408.6 picometer. Okay. So here this picometer you need to convert it to meter. Okay, and atomic mass is given, that is 107.9 U, that is unified mass. And what you need to do is you need to calculate the density of silver crystal. Okay, so since the question it is asked to find the density of the silver, you need to find the density. So first we'll write the formula. Okay, so density, that is D. So density D, it is equal to Zm by A cube Na. Okay, so this is the formula. Density is equal to Zm by A cube Na. So what we need to do, we need to get a substitution for all these terms and then simplify. That is the thing. So first one is Z. Okay. Now we'll see. Z means what? Z is the number of atoms in the unit cell, isn't it? Z is the number of atoms in the unit cell. So here in the question it is given that it is a CCP lattice, or I have said that it is an FCC crystal. So you know how many atoms are present in FCC crystal, isn't it? So since it is CCP lattice, since the lattice is CCP, or you can say it is FCC lattice, isn't it? It is FCC lattice. Number of atoms in the unit cell. Okay, number of atoms per unit cell will be equal to 4, and that is Z. Okay, so number of atoms Z is equal to 4. So this one you got, Z is 4. Now the next one is molar mass. Okay, so you need to find the molar mass. In the question they have not given molar mass, but they have given the atomic mass. Okay, so you know that atomic mass, you know the difference between atomic mass and molar mass, you have already studied in first year. Okay, molar mass, it is the mass of 1 mole of a substance. Atomic mass, it is the mass of one individual unit of a substance, that is mass of one atom in a substance. Now if you take 1 mole of a substance, then the atomic mass in AMU, or in U, that is unified mass of that substance, it is numerically equal, that is in number it is equal to the mass in grams, that is equal to the mass in molar grams. So if you consider 1 mole of a substance, then the atomic mass in U and the molar mass will be same. So you can write it as molar mass, that is molar mass is capital M. Capital M, it is equal to 107.9, same as atomic mass, gram per mole. When you write the unit, it is molar mass. Okay, gram per mole. So here, since it is in grams, you can convert it to kilograms, because picometer will be converting it to meters. Okay, so you have to convert grams to kilograms. So you know how to convert grams to kilograms, isn't it? So I'll just write it here. You know that 1 kilogram is how much? 1000 grams, isn't it? 1 kilogram is 1000 grams. So here 107.9 grams is given. That is how much or how many grams. That is what we need to find. This cross multiply. So 107.9 into 1 divide by 1000 you will get. That is 107.9 divided by 1000. Either you can get the value here, or what you can do is this 1000 you can write it as 10 to the power 3, isn't it? 1000 you can write it as 10 to the power 3. 10 to the power 3 is 1000. So this 10 to the power 3, take it to the numerator. So you'll get it as 107.9 into 10 to the power minus 3, because plus 3 when you take it to the numerator it will become minus 3. So this you can write it as 107.9 into 10 to the power minus 3 kilogram per mole. So this is just a side calculation. Okay, so this is the thing. So 107.9 into 10 to the power minus 3 kilogram per mole you will get. So that is what you are going to substitute here in molar mass. So you got Z, you got M. Now A. A is already given in the question, that is 408.6 picometer. A is edge length, isn't it? So I write it here, edge length. Edge length, that is A. A is how much? It is given as 408.6 picometer. 408.6 picometer. Now you need to convert picometer to meter. So 1 picometer is 10 to the power minus 12 meter. Okay, 1 picometer is 10 to the power minus 12 meter. So this value you need to convert it to meters. Okay, so how will you write? It is 408.6 into 10 to the power minus 12 meters. Okay, so 408.6 into 10 to the power minus 12 meters. Now this value you can substitute here. And the last one is Avogadro number. You know already. It is 6.022 into 10 to the power 23. Okay. So you got all the values here. Now you need to substitute in this equation. So D, density is equal to what is Z? Z is 4. So 4 into what is M? M is 107.9 into 10 to the power minus 3 divided by what is A? A is given as 408.6 into 10 to the power minus 12. It is A cube. So you have to cube it. Never forget to cube it. That is when you write problems or when you solve problems, usually you'll forget to do this cube. You just write A, then Avogadro number, and you just simplify. You'll get a wrong answer. So never forget to cube this. This is A cube. Always you have to remember that. So 406.6 into 10 to the power 408.6 into 10 to the power minus 12, then cube, okay, into Avogadro number. Avogadro number is 6.022 or 23, anything is fine. 6.022 into 10 to the power 23. It is not minus 23, 23. Okay, 10 to the power 23. So you have to solve this. Density is equal to, now 4 into 107.9 into 10 to the power minus 3. When you simplify, you will get the answer as 0.4316. Okay, you will get 0.4316. Now this part if you do, that is 408.6 into 10 to the power minus 12, the whole cube. Okay, that part when you do, you will get the answer as 6.82 into 10 to the power minus 29. Okay, that multiplied by Avogadro number, 6.022 into 10 to the power 23. Okay, so these calculations you can do only step by step. When you do it all together, you may get an error. So it's better to do in step by step method. So first you can multiply this, then cube this value. Okay, only this value cube into 6.022 into 10 to the power 23. Now this part, this 2, you can multiply 4316. Multiply these two, you will get the answer as 4.107 into 10 to the power minus 5. Okay, now if you divide these two values, when you divide this, you will get the answer as 10508.88 as the answer. Okay, now we need to change the decimal. Okay, so change the decimal from year to year, 10 point. Okay, so take it as 10.50. Okay, so this decimal, it is 1 2 3 positions, so it will be 10 to the power 3 positions. Okay, 1 2 3 positions, so it is 10 to the power 3. Since the decimal we are changing it to the left side, if it is left side, it is positive value. Okay, if it is in the right side, it is negative value. You know that if it is in the right side, it is negative value. So if it is in the positive negative side, sorry, if it is in the left side, then it is positive. Since we are changing the decimal to a left side, it is positive value. So we'll get as 10.5 into 10 to the power 3 kilogram meter cube inverse. Okay, so since we are using a kilogram, so you can see a kilogram and meter, so it will be kilogram meter cube inverse, or you can also write it as 10.50 gram per centimeter cube. Okay, 10.50 gram per, when you remove this you can write it as gram per centimeter cube or either kilogram per meter cube. Okay, or gram centimeter cube inverse. So this is the answer. So this is how you solve the problem. So you have to see the units properly and all the units should be same, and then substitute in this formula and do it step by step, otherwise the answer will be wrong.